Hi everyone. Unfortunately, there are some visa issues, so that I cannot attend face to face this time. And I just saw in the camera there's a lot of old friends and new friends in the joining the AMM, and it's really our pleasure that all the people can really join this AGL event. And thank you so much. And I think there have been already four keynote sessions talking about the overall what AGL is doing and what is the future vision of AGL. So maybe in my sessions I giving a more little bit details and connecting with also other technical insight sessions that you are going to hear about during the next 2 days. Okay, so wait a second. Okay, before I go into the detailed sessions, I will just give a very brief introduction of myself. I'm Jerry Zhao from Panasonic Automotive, and I graduated in 2017 and joined to my company, and this is my 8 years in my company. And yes, 8 year in my company, and actually also the fifth year in AGL. So since my third year in the company, I became the virtualization expert group leader of AGL, and now it has been changed names to be SDV Expert Group. And this is really glad to that I can really have this golden opportunity to work in the AGL community. So on the other hand, actually, since this year, I'm also adding a new role to be the Sophie APAC Regional Hub chair. So this probably enable future inter-community collaboration and chances, and that's something maybe beneficial for the whole industry. Regarding my hobbies, traveling is my best hobby, but unfortunately this time because of visa, I'm not able to travel there. So it's really a pity, and games and also pets. So regarding today's agenda, I will give a general background and what happens in the automotive and what we are doing in the SDV-EG, and also giving a introduction on what we are going to do next. Especially, probably you have already heard of the AGL SDV Reference Platform from the keynote speech. So let's first come with this topics. I think from the keynotes you have already heard about the different point of views of illustrating SDV. So maybe from my perspective, I giving a very daily use cases or daily life experience on what this software defined means. So this is highly actually related to my recent experience since last Berlin AMM last year. So I changed my rent home and to be a larger rooms in Japan. And there was a new problem for me. So how to clean my new house, because besides the normal work, I also have the community work like AGL and Sophie, and so I cannot do everything by myself with this kind of vacuum cleaner from Dyson or even from other brand. So actually, in the end, I bought this robot vacuum. So this kind of thing is really powered by some AI logics and different connectivity activities with mobile phones, so that you can control everything from your mobile and really release your hands. So this actually definitely one of the explanation of how software defined actually changed our life. And also another experience that I started to raise a cat since last November. And again, I need to work, then how to feed my new cat. So maybe traditionally you have the pet feeder, but with some mechanical buttons and the pressure sensors maybe, but you can really difficult to control it, and you either need to manually do it, or the I mean the volume of the feeder cannot be controlled. So last, actually, I bought a smart pet feeder. So it's a digital, it's controlled with applications. It's also powered with AI that can giving monitor of the pet health, and give appropriate volume of how many pet food he should eat. So all these kind of things is actually a transition of the hardware or mechanical defined to a software defined, which is always updating, which you always probably can have the continuous subscription for some more advanced functionalities. So for example, for this pet feeder, you can actually having a vlog options, so that you pay a little bit money, but the applications can record your lovely cat videos for when he's eating, and you can post it on the SNS. So this giving a general trend from the hardware defined to software defined. So from the left-hand side, all this kind of, for example, computers, phones, and watches, which all this kind of products value defined by the hardware and the mechanicals, to a recently Note PC, smartphone, and smartwatch, all these kind of things, more software defined, and the value itself is defined by the software. So all these kind of things is called software defined. Everything starting from PC, various devices, has become intelligent thanks to the evolution of the software. And maybe this is the general background of the software defined. And for SDV, maybe you can have already heard this in the previous sessions. It's just one of this kind of overall trend, although automotive has the most volume of software compared with all other their devices. And in order to having this software defined vehicles, or a concept or development style from the hardware first to software first, that need to be emphasized. And I think this is the overall trend for the industry, and also what AGL committee is heading to. And under that, actually, when you looking the overall architecture trend for the generic computings in the history, there's always a cycle between the centralization and distribution. So all this kind of hardware and software relationship always changed. But one thing is never changed, is that how to decouple software and hardware, how to utilize virtualization or abstraction to decoupling software and hardware is never changed, and always been the similar thing that people are trying to assume. And definitely the automotive industry is also following a similar path, and we are doing the quite similar things, and we really come to a very important era to fulfill this kind of evolution. And from previous pages, I already explained actually that no matter what kind of the architecture is changed, the one key concept is to having the hardware and software to be really efficiently coordinated, or say work together with each other. So that means you need to have the correct logical architectures decoupled in two perspectives. One is to decouple the applications from the operating systems, that you need a OS agnostic application framework. On the other hand, you need a hardware agnostic virtualization framework, which you decouple the operating system from the hardware. So this is definitely the same concept that we are having in the automotive industry. And I believe in both Toyota's keynote and Panasonic keynote. So there's a important of the this kind of logical architectures to decoupling the software and hardware, and that is one of the big direction that AGL has been working for this recent years. So generally, we leveraging this already well-established standards of VirtIO from the server world, but also extend to the automotive field to make it capable for different use cases, and make the software and hardware can be really decoupled from each other's in the automotive use cases. For this VirtIO front-ends, contributions will be still continued in the AGLs to support more activities. And definitely, I think for the SDV reference platform, the SODIF, there probably more backend support also together with the Zen hypervisors during the development in the community. We also have worked on different non-hypervisor environment for the VirtIOs. We call it VirtIO loopback to actually make the VirtIO framework also capable to be running on both non-hypervisor environment and hypervisor environment. And this also definitely having a conceptual development of multi-container use cases to supporting different containers and using the VirtIO drivers to doing the device virtualization and coordination. And this kind of development, so starting from basic devices to also this container use cases with priority scheduling implementations. And we originally we haven't finished the GPU, but actually this time Michelle, so our virtual open systems team members, is also in the SDV Expert Group, will giving a deep in-depth in these topics to talking about how they are enabling the VirtIO loopback or this non-hypervisor VirtIO with the we host a user GPU. Besides the hypervisor and non-hypervisor environment, we also have a extension of the VirtIO's frameworks to be a multi-ECU or say multi SoC environment. And one of the great example is for the displays. We constructed the unified virtual display based on the VirtIO GPU, and also having adding a new some further components like this distributed display framework to enable the flexible layout controls of applications across multiple displays. This has been already integrated in the AGL UCB and already available for anyone to have a trial with it. So with the use of the unified HMI, you can definitely transform from the legacy HMI system to be a more unified HMI system. You can really have the full flexibility on ECU and function display for the cockpit UX innovations. You can imagine all the displays in the cockpit or cabin can be virtualized into a big virtual display. so that you can flexibly display your application contents on any displays without dependencies on the hardware or underlying in systems architecture. So this is for the UI UX perspective. On the other hand, we also have some experimental work with some partners like ARM. They are also active in both SOFI and maybe some also further activities in the AGL. That we constructing this concept of the display zonal architectures to give more freedoms for people to select whether to centralize all the GPU power into the central computer or optionally that distribute some powers to the zonal controllers to make the harness to make the weight of harness, the cost of a harness to be more optimized with some even cheaper Ethernet cables to connect it with each other. And with this kind of things, you can centralize all the applications into the central computers, but offload the graphic renderings to the zonal ECU. And it can also giving you flexibility to adjust your OR system architectures across different generations or different grids. So it depends on the how many displays are you going to use. You can utilize this kind of framework to freedom to flexibly adjust your system. And another major update that we are also going to cover in this AMM is a big upgrade for the unified HMIs that in the past actually we the original unified HMI framework have to customize a little bit for different operating systems, and you need to develop you need to have or adapt a plugin for different operating system or different Windows system. But we upgraded architectures since last year, and there's no need for any additional adaptations for the each OS anymore, and all this kind of layout and composition can be handled with the unified HMI frameworks directly. So that's probably so greatly enabled that similar architectures can be achieved in different operating systems. And we already released most of this kind of major update in the GitHub already. Although some part is still under refactoring and will be released soon. And we are going to start the AGL UCB contributions across the next few months, and finally giving some demo with the newly upgraded Unified HMI at the Open Source Meet Japan, the AGL event. For the details of these topics, it will be covered by Murakami-san from Panasonic Automotive Systems in tomorrow's sessions. Last time he's absent because of the wedding ceremony, and fortunately he came back and with the blessing, and he started again the committee works. Please welcome him and say hello to him. Another thing is for the VirtIO adaptation for the cloud to achieve the binary compatibility in cloud automotive hardware through VirtIOs. So we have developed a environment called Virtual SkipGen, and this maybe can be a virtual reference platform for the community use and advertising AGLs, which probably need more discussions, but we can definitely see this to be a virtual version of the SODIF, the AGL reference platform. You can see already the demo the demo in the demo area, and please also talk with our engineers, Ms. Dani-san. Also related to this cloud native environment, we definitely think that the cloud the cloud virtual hardware there's some missing for some hardwares or some peripheral devices on the clouds. You definitely need to construct a framework to simulate this kind of things. We are trying to creating this kind of systems based on the standardized virtual interfaces and using DDS and also creating some simple models. And for this kind of work, we are also considering to contribute maybe during the next year. So all of this is the existing committee activities, and so from now on, I will probably giving a more introduction of the AGL SDV Reference Platform, which actually enabling the next journey of AGLs, also taking the all these assets that has been already developed in the AGL committee. So maybe you have already seen the flyer, and also in the keynotes, you will probably have already seen these slides. So SODEF is a really new initiative from the AGL SDV Expert Group, first initiated by Kusakabe-san. And so this kind of framework is to provide a open source SDV reference implementations that combines AGL UCB with multiple open source projects under Linux Foundation, and also future, for example, other communities like Eclipse Foundations, Sophie, and even Jasper, as mentioned in the Honda keynote. So the SODIF, so we definitely don't have a unique definition of what's kind of the full name of SODIF. You can remember as whatever as you like. You can probably call it SDV plus open or ecosystem, or you can also see the SODEF is the first characters of software development. So there's no bonding of the meaning of the SODEF, but please feel free to select one of the way that you can easily remember it. And currently, we, as the first step of this SODEP, we have already considering this UVXYZ. So I put it in the in order to easy to be remembered. The Unified HMI, VirtIO, Zen, and Yocto and Zifa to be the first target of the AGL SODEF, and definitely even more SDV enablers to be integrated and incubated during the development of this SODEF platform. And regarding these topics, there's a co-related presentations from Kusakabe-san, and I also very glad to announce that Kusakabe-san have been already the co-leader of the SDV Expert Group. And if Kusakabe-san, you are in the room, maybe shake your hands to let everyone to know you. Okay, so regarding this AGL reference platform, as I mentioned, so we have already included some of components, which actually most of them has been probably used in different production programs from different companies. So it's more realistic things. And for the futures, maybe even some romantic things like how to having the real-time Linux enabled in the AGL reference platform, and how to decouple the software and hardware for that. And also, so definitely there is a lot of new trends for the SDV to using containers, using Kubernetes or K3S. And also all this cloud native initiatives that can be the potential enabler of SDVs to be integrated into AGL. So that's it's more about reinvention of the existing automotive architectures. So I call it fantastic. So with all these kind of things, so we are trying to work on the hardware agnostic device virtualization framework and also the OS agnostic device service manager and framework and automotive grade Linux. So we take this AGL and finally we hope to make it automotive grade Linux. So it's a very similar pronunciation, and I think this is definitely the final goals that we are trying to work on during the committee. Last but not least, so we have our SDV Expert Group calls every bi-weekly in the Tuesday evening in Japan time, and I think it's afternoon in the Berlin time, and welcome everyone to join to the discussion, and let's do be the collaborate together with the AGL and to make this kind of realistic, fantastic, and romantic future of automotive. Thank you.